Hello everyone, I'm Chong Wang. Now I would like to introduce our recent work on interpretable image classification by using support and trivial prototypes. Models interpretability is very important, particularly for some high-stakes tasks. And protopinet is a good interpretable model because it can associate its classification predictions with a set of class-specific training prototypes. However, in this work, we noticed that the original protopilet tend to only focus on trivial prototypes. In other words, those prototypes are easy to learn and far from the classification boundary as shown in the figure A. And in this work, we propose to learn the support prototypes that are near to the classification boundary. That means they are hard to learn. So basically, in this work, our contribution is we try to learn the support prototypes that can benefit the classification accuracy and interpretability. And we also make an analogy between the prototype learning of protopinet and support vector learning of SVM. For example, in this figure, we notice that our support prototypes are indeed located near to the classification boundary, just like the support vectors in SVM. And in this work, we also introduce a new interpretable method called ST-protopinet. The ST-protopinet contains two parallel protopinet branches. The first branch is the support protopinet, which can utilize support prototypes for classification. Those support prototypes are learned by minimizing the prototype distance between classes. We also have a trivial branch. The trivial branch utilizes trivial protopinet for classification. Those trivial prototypes are learned by maximizing the prototype distance of different classes. And finally, we generate the final classification logic by ensemble the two logic from the different branches. We perform experiments on the three fine-grained benchmark datasets, the cube, the Stanford cars, and Stanford dogs. And in the first table, we notice that the support protopinet can always perform better than the trivial prototypes, and also some other prototype-based method. But our proposed ST protopinet can perform better than the support protopinet because our method utilizes the two complementary set of support prototypes and trivial prototypes. In this work, we also use some objective interpretability measures to evaluate the model's interpretability. We notice that our ST protopinet can generate the best interpretability result. In this figure, we show the difference between support prototypes and trivial prototypes. We notice that for the support prototypes, they tend to focus on the object regions and even share some common characteristics between classes, such as the bird's head and the bird's belly. And in the TSNE result, we notice that those support prototypes are indeed located to near to each other, and they are inside the feature distributions. While for the trivial prototypes, they not only focus on the birth region, but also focus on some irrelevant background regions. And in this figure, we show an example of the reasoning process of our method. For example, in the support protopinet branch, our method compare the input image with the support prototypes and to generate the logic from the support branch. And the same process will happen in the trivial branch. and generate the trivial logit. The two logit is summed to generate the fellow classification logit. And finally, I would like to particularly thank the support from the BRACS project and Australia Research Council grant. Thank you for your attention to our work.